Hello, everybody. Can you all hear me? All right, good morning. So people are still coming in, but I'm just going to jump right into it. So my name is Babeanu. I'm an identity solutions architect with Nulli. We help our clients implement sometimes complex identity and access management solutions. And in the past couple of years, we've had a number of clients in the IoT sphere. So this is what I'm going to talk to you about today, how graph databases can help you improve your access management policies and make them more scalable and easier to maintain. So I'm going to start with a bit of background. Just actually interestingly, had this discussion in the past couple of days with a number of people here about what an identity is. And so we, at Nulli at least, define an identity as anything that can be authenticated or authorized. So what we mean by that is it could be, of course, people, smart devices like mobile phones and tablets, as well as cloud services, and of course devices. So I'm going to focus today on devices. Here we have smart sensors or smart cars. And sorry, the interesting piece here, the piece I'm going to talk to you about today, I'm going to focus on is authorization. So in this speech, I'm going to assume that all the identities have already been authenticated by some means. So given that, how do you enforce authorization? Well, through the use of access policies. So an access policy can be sort of represented like that. You have an identity and a resource, and essentially your access policies has to say that your identity can access the resource. So you can hard code it like that, or you can maybe just deduce it, but in the end, that's what you want to do. So whenever that identity tries to access the resource, you can easily answer the question, yes or no. So what about graphs then? What are graphs? Before we can even talk about graph databases, be good to understand what a graph is. So how many of you are familiar with graphs already, just so I know? Everybody? I guess I'll go pretty fast here. So as you know, a graph is like a representation of your data in a graphical way that includes vertices and edges. So something like this at the bottom, you have six edges that are, six vertices that are interconnected by edges. Actually, interestingly, this thing here is a graph as well, as I see it. So then back to our access policy, this is a graph as well. We have our vertices and our edge. So as you can see, hopefully this starts to fit together now. So if you start looking at things that way, you realize that graphs really are everywhere. Here's an example. Let's take this little graph, and we have three people, Jenny, Bob, and Mike. So Jenny loves Bob, and Bob has a friend, Mike. Jenny has a car, a Renault, and Mike has a car, a Porsche, and they're both red cars. So this is a pretty simple representation of something that exists in the real world. Now here's an access policy. People only lend their cars to their friends, right? So pretty easy. So question, can Bob borrow Jenny's car? Well, I don't know, looking at this graph, there's no actual friendship relationship between them two, so you can probably say no in that case, but I'll leave it up to your interpretation. We'll get back to this example. So a word about graph databases then. So now that we've seen what graphs are. So graph databases, I'm sure you're all aware, but just in case, there are databases. There are NoSQL databases. They use graph structures to represent their data. They use vertices and edges. They are highly interconnected structures, and they're more relational than relational databases, really. As you can see, all these relationships between all these nodes make them very, very relational. And they support big data. Just to show you, so as a graph, as a database, you need some kind of a language or to make queries. I'm just citing here an example. We've been using this language called CYPHER quite a bit. There are others out there. I'm sure some of you here have other technologies that you use. The reason I mentioned CYPHER, which was created by a company called Technologies, is because they open sourced it. So you put the list, the thing here. the URL here. So you can actually use it in your own custom applications if you want. So I just jotted down some examples here to show you what this language looks like. As you can see, it's basically a textual representation of your relationship. You have a person, say for example, a person, Jenny loves Bob at the top there. It's pretty easy straightforward to read. In general terms, you can generalize it like a person loves a person has a friend, or a person owns a car, and a car has a color. So this is just some kind of general relationships based on the little graph I showed you earlier. Good, so let's have a look at a CYPHER query just to see how that would look like for our access policy. So here's the question: can Bob borrow Mike's car? So remember the little graph I showed you earlier? So can Bob borrow Mike's car? So in CYPHER, the keyword, unlike SQL where you have select, in CYPHER the keyword is match, and that is because we're trying to match patterns to the graph. So can we find in the graph a pattern like that? The pattern we're trying to find here is a person that owns a car and is also a friend of another person. So we have two persons and a car. And in that case, we want to say where one person is Bob and the other is Mike. So based on the graph we had, if we run this query on the graph database, you would get this output, these relationships. Pretty straightforward. So in that case, the pattern has been matched, and yeah, so this Bob can borrow Mike's car. If we ask the same question with Jenny, well, in that case, we cannot find a pattern in the graph I showed you. So in that case, no access. So that's basically all the primer I had on the graph database. So now for a real example. I was recently helping a customer, which is a big manufacturer of IoT devices for industrial devices. They look like this. These are sensors that are in refineries worldwide. There are flow sensors, temperature sensors, and what have you. The interesting thing is that they're all connected, and most of them have multiple functions. So it's not only a temperature or a flow sensor, but you can also regulate the flow with them. So they have different capabilities. So they need different types of accesses. So what problems were we trying to solve there? So first of all, volume. There's obviously over hundreds of millions of devices spread worldwide in all these geographies. So we needed to identify all of these and protect them as resources, and also make them work as identities, because they also needed to connect to each other in lots of cases. So those complex relationships between identities, we were trying to look at ways we could model that. So of course, looking at SQL database or even LDAP, but all of these were really hard to model in a traditional way. For example, looking at SQL databases, it's really hard to model things like directional relationships or friend-of-friend relationships, which often include lots of joins that you have to do on your tables. Basically a table join explosion at that point. So really how to make that perform. And also things like path queries, like is there a path from one edge to from one vertex to another, like from a node to another? Is there an actual path? And also the will of that client was to implement a true IRM system, a true identity relationship management system. So Graph was an ideal fit for that. So here's some real use cases that we solved with Graph. For example, as a service, I need to be able to read data from a device. Pretty simple. We have a service, and we have a device, and it can read the device. Simple. This one, as a factory worker, I need to link a device with the IAM platform using an app. So in that case, we have a user who has already registered with that app, and that user had a new device that they needed to install on the factory floor, and so the user signed on to the app, paired the device with the app, and then declared himself as the owner of the device. So that built this graph in the backend, and as you can see, graphs are dynamical things as well, so they evolve over time. So this is an example of an onboarding of a new device, and now, going forward, whenever that user tries to, or that app tries to access a device, well, the policy is already in place, so it's really easy to use CYPHER to just read that to find a pattern there, as I showed you earlier. I just want to show a last use case here. As a building owner, I need to be able to grant access to all or part of my building to certain users. So, for example, technicians who need to maintain some devices. So this is what it could look like. On the lower left, we have the building owner, J. Doe. He owns building D, and that building is made of several floors. Each floor has a certain number of devices on them, like, for example, device 1, device 2, and user T. Smith needs to access them so he can maintain them. So similarly, we can just add this relationship here, and therefore, going forward, we can find a path between T. Smith and any of these devices there using CYPHER fairly easily. Now, if we put it all together, in the case of my client, we ended up with something like this. This is a graph model that just represents one instance of all the possible nodes that you can have. Just imagine 100 million of these, right? So this represents all the use cases we had, in that particular case. So you have in blue, you have your identities, you have your devices, you have building and locations. So hopefully it gets you an idea. So based on that, we can run queries and find easily who has access to what. A quick on the project status, where it's not quite live yet. We expect to be live by the end of this year. We tried, as I mentioned, other ways to do it. With LDAP, it was really complicated. We had to replicate data to make it perform. It wasn't really something easy. The queries that we end up making are more intuitive. They're simpler and easier to maintain. You can actually visually represent this in a UI, so you can actually see what's going on. And so that makes it very easy to maintain as well. So now, as a side note, I'm just going to have a little brief thing here about semantic data modeling, because this is something that happens for free, if you want, once you build your graph. This is more like on an idea. It's like a tangent on the project, nothing that we've actually used yet, but just ideas worth considering maybe. Why am I talking about that? Well, let's see. First of all, what do I mean by semantic model? Well, semantic means inserting knowledge into your data. So what this tries to do, it dates back to the semantic web from the early 2000s. They have formalized quite a few things when they're trying to do the Web 2.0. And one of the things they formalized then is this concept of domains of knowledge. And there are several domains of knowledge. And in order to describe them, you need a certain number to define a certain number of objects that create what they call an ontology. An ontology at the core is a graph. So when you have a graph like that, it describes the classes of your domain of knowledge, the attributes, the relationships between them, the rules, the axioms, the events of your domain of knowledge. So in essence, this is the ontology of your domain of knowledge. And you get this once you've got your graph, you have this. So you don't have anything else to do. So it's up to you to use it or not, really. So why is that interesting, or at least it's interesting, is that every organization has several domains of knowledge. They have, the access management one, but you may have, an engineering ontology, a marketing ontology, customer relationship ontology, and they all interact with each other, really. And the interesting thing is that the knowledge is the same whether you're in an ontology or another. A device has the same meaning whether you're speaking about engineering, customer support, access management. So you can actually reuse the knowledge from other ontologies for your own purposes. So why is that interesting? Well, you can ask natural questions. You can, since the data is interoperable between the domains of knowledge, you can actually use that. Why not build access policies that also use, marketing knowledge or engineering knowledge? You can bring it all together. So more intelligent access policies, and hopefully, oh, I see here a slide that I actually removed, but that's okay. Machine learning. As we've heard a lot about machine learning this week. even this morning, I think that a graph like that and a set of ontologies would be a great data set for machine learning. Like if you had, machine learning especially supervised machine learning requires a big labeled set of data. So if you've already got that, if you have your graph, so then it would be easy to use this data. I mean, easy, not easy, but you would actually be able to use this data and train your machine learning supervised algorithm. And that could actually then maybe make policy decisions for you and generalize your access policy decisions. So, and actually that could feed back into the model itself, because as I mentioned, graphs are dynamic, so why not also update the graph as you go? So a quick note on graph projects. So going back to reality now, I've just given you these tangent ideas, just food for thought. So what does a graph project look like in our experience? Well, graphs are really high-level conceptual things. I mean, we can go to a whole lot of nitty-gritty details for sure, but at the core, it's really abstract and really high-level. So what we find successful is to start with the business use cases. I've shown you some use cases we've solved, and we've really started them from the top down. Like, what am I trying to do? Who is trying to access what, or what is trying to access what? Once you've defined your use cases, then everything is a graph really, so it's easy at that point to actually draw the things on the board. So you can draw your use cases, and more often than not, that becomes your graph. Then you can select a vendor. You can think about data migration or data synchronization. There are some tools available. Some vendors propose their own tools. I've put here a little link to something I wrote that pulls your data from LDAP and publishes it in the graph. You can have a look at it if you want and improve on it. And you can integrate that with an IAM platform. Some vendors, we are partners with Neo Technologies, so we use Neo4j, but it's probably one of the more popular ones, but here are some others, OrientDB, Titan, Apache Giraffe, GraphDB. There's also linked a page here for a ranking of all these graph database engines, if you want to have a look at it and select which one is more suited for you. Yeah, that's essentially what I have for you this morning. It's a really brief overview of ideas I hope you find interesting. If you have any questions, sure.
Did you say you're using Neo4j for your underlying data store, or is it something else?
Yes.
Okay, and how do you achieve geographic redundancy and data consistency?
Well, this was, it's not live yet. This, as I mentioned, the project's not live. So Neo has come up with a new infrastructure where everything's in, they use basically swarms of containers, their own brew. It's not like Docker, but, and so that's how they use that with replication, and they have smart, like a smart management node that manages those things. So that's essentially how it's done.
One question here.
Yeah.
Can you share more about how you integrate with IAM platform? For example, do you abstract the relationships into some kind of authorization rules? I mean, what that integration looks like?
So, at least Neo, and I'm sure the others have a set of REST APIs. So that's basically the main integration points through REST. And so it's essentially boils down to creating those CIPHER queries and running them through REST. So from our IAM platform, we have we built some custom code to build the queries based on the request that came in. So URL-based request, and then based on that, we deduce the CIPHER query that we need to run and just make a REST call. Yep.
Hey, hi. So I have a question here. There's been a research area called model-driven security for like 20 years or so. And incidentally, so we've been working on this and it's for 10 years or so, and it sounds like this is somewhat related to that research field. So I wanted to, I don't know if you're aware of all the publications in this field. If this
no.
is, it sounds there's a flavor of that, that research that people have been done over the 20 years or so.
Oh, wow. Okay.
Is that an accurate assessment or not so much?
Well, possibly. I wasn't aware, but I'd be glad to learn more about it. We are actually been talking with some researchers at the University of Calgary who are looking into formalizing some of this based on real use cases. So we do have some connections with research, but I'd be more than glad to talk to you about.
I'm glad to share. There's anyone from IBM Zurich. I think this is, has been very active. About 15 years ago, universities have spent a lot on, they didn't use graph databases back then, but ontologies and semantic, just other models.
Back in the early 2000s, yeah.
Yeah, so it'd be interesting to see how would you contrast it if you know any of that stuff?
Well, I mean, when I looked into it, the semantic standards they came up with in the early 2000s, I mean, part of it was a GraphDB. So it's like pretty much that's where their ontology resides. I mean, it just makes sense, right?
In your example, you have showed CYPHER as a query language.
Yeah.
Is there a reason for not using Gremlin, or have you guys evaluated?
For not what, sorry?
Gremlin query language.
Yeah.
Which looks to be the more standard way of querying graph databases. So
I think it's still in the works. We're just talking about that, but yeah, it's in the works. I guess right now there are several. It's not a unified. I think that's one of the reasons why Neo open sourced their language to try and make it maybe the standard. That's maybe their hope. But there are other ways to do it. So there's no standard right now, and I think some researchers are working on that as we speak. I'm pretty sure at universities. So not yet.
Okay, we just have time for one more question, and then we'll take 5 minutes for the next presentation.
I'm going to try and take an implicit bias out of this question, which by declaring it, I'm not going to. Do you think that it would be a good idea, rather than, it's actually a follow-on from the CYPHER versus Tinkerpop question, is do you think there should be some kind of identity graph access protocol that we standardize on within the identity industry, rather than necessarily, as you say, you're exposing CYPHER over REST. Right. Somebody else might be exposing Tinkerpop over REST.
Yeah, I agree. It would be a worthy endeavor. I agree. Yeah.
IGAP.
Yeah. We're still in the early stages, obviously. I mean, for this, anyway, thanks.
Okay, join me in a round of applause.